we are going to take a look at the rest of the adding and subtracting problems in your notes packet. You should have had number 3 finished from yesterday. If not, pause this video and please take a look at these steps and finish it now. For number 4, we are going to start a lot of these problems by factoring that hadn't really come up in the first 3, since most of the denominators were monomials, but when we start getting into binomials and trinomials as denominators, we are going to start to factor. And if you look at these two denominators, one is b minus a, the other is a minus b. Please don't forget that you can take a negative sign out of those denominators. So for the first fraction, we are going to take a negative sign out of b minus a, and you get negative a minus b. So what does that make our LCD? If this first fraction has a negative and then a factor of a minus b, this second fraction has a factor of a minus b, our LCD would be negative a minus b, which means this first fraction is going to stay just an a. It doesn't have to get multiplied by anything to be over our LCD. The second fraction would be multiplied by a negative 1, making it a negative b. And then it just so happens in this one that our numerator is going to match part of our denominator. We can take this entire numerator, the entire thing, and cancel it with a factor from the denominator, leaving just a positive 1 in the numerator and a negative in the bottom, which ultimately reduces to negative 1. For number 5, here's where we're starting to get into factoring first. For our first fraction, our denominator is w squared minus w. You can factor out a common w, and you'd be left in parentheses with w and minus 1. For the second fraction, that is the difference of perfect squares, you're left with w plus 1 and w minus 1. So as you're looking for the LCD for these two particular fractions, this one has a factor of w minus 1. This one has a factor of w minus 1 and w plus 1. You can kind of think of the LCD as a collection of factors. We have a factor of w, we have a factor of w plus 1, and we have a factor of w minus 1. All 3 of those are going to be part of the LCD. And since this one we're only working with one variable, we can write our excluded values. There are 3 numbers that w cannot be based on this denominator. W cannot be 0, w cannot be negative 1, and w cannot be 1. Any 3 of those numbers would force your denominator to 0, and it would result in an undefined fraction. Alright, so let's get started actually simplifying this. The first fraction is missing a factor of w plus 1, so you're going to take the 5 and you're going to multiply by that missing factor of w plus 1. That'll put that particular fraction over your LCD. The second fraction is missing a w, so we'd multiply the 1 by w, thereby making it over our LCD. Now the LCD is going to stay as you start to simplify. You do want to distribute this 5 into that parenthesis and then combine like terms. 5w plus w gives you 6w plus the 5. Again, still over our LCD. Now you would at this point check to see if you can factor. Since you cannot, this becomes your final answer. For number 6, we have to deal with the negative exponents first. So the first thing we're going to do is flip these fractions over. This negative brings this factor of x minus y into the denominator. Same thing with this other negative. It brings the factor x plus y into the denominator. And I tend to like to write these as addition problems, so I normally take a negative, if it is in the middle here, and put it to the numerator of that fraction. Now you can look at your two fractions. What is your LCD? Well, we have a factor of x minus y and a factor of x plus y. The LCD is going to be a combination of the two. Now, since it's two variables, we can't do this part. We don't know what values are excluded. It would depend on what numbers each of those were. But we can still simplify. So we're trying to get it over the LCD, x minus y, x plus y. The first fraction needs to be multiplied by x plus y. The second fraction with that negative 1 needs to be multiplied by x minus y. Once you do that, you want to distribute, so we're going to distribute the negative 1 here. Careful on the distribution, because after you do that, you should have a negative x and a positive y. Still over that LCD, which when you combine gives you 2y over the LCD. And if at any point I'm going too fast, just rewind the video a little bit, utilize the pause feature, and make sure you're getting this all down in your notes packet. We are going to go through two more problems, number 7 and number 8. And for number 7 and number 8, we are going to start by factoring these denominators. This is a short trinomial. Two numbers that multiply to positive 6 but add to negative 5 are negative 3 and negative 2. So we can go right to the factors once you figure out those numbers. For the second fraction, this is the difference of perfect squares. So it's going to factor into z plus 2, z minus 2. And again, your LCD is basically a collection of factors. This one has a z minus 3 and a z minus 2. This one has a z plus 2 and a z minus 2. So if we start to collect these factors, we have a factor of z minus 3, a factor of z minus 2, and a factor of z plus 2. Since this is a single variable, we can write our excluded values up here. Z cannot equal 3, z cannot equal 2, and z cannot equal negative 2. So those three values would be excluded when we go to solve these. Right now, though, we're simplifying, but it's always a good habit to write these numbers up here if you only have one variable. So, our goal is the LCD. Let's figure out what we need to multiply by. This particular fraction is missing z plus 2, so we're going to take the 3 and multiply it by z plus 2. This second fraction is missing z minus 3, so we're going to take the 2 and multiply by z minus 3. Again, keeping it on over the same denominator, you're going to simplify. Distribute the 3, distribute the 2, and you should get 3z plus 6 plus 2z minus 6. When you combine like terms here, you're going to end up with 5z over the LCD. Now, obviously, there's no way to factor 5z, so you are done at this point. For number 8, you're going to start off by factoring as well. X minus a does not factor. X squared minus a squared, that is the difference of perfect squares. That factors into x plus a and x minus a. X plus a on the third fraction does not factor, so it stays as is. And as you look down through all your factors here, the factors that are included in the least common denominator are your x plus a and your x minus a. Now start to look for what you're missing. The first fraction that includes an x is missing x plus a. So that's what we are going to multiply by. The second fraction isn't missing anything. But do you notice here how this fraction is getting subtracted from the rest? That subtraction goes to this entire fraction. Both the x squared and the a squared. So what I did in this step is I distributed that negative to both the x squared and the a squared. Both of those terms are getting subtracted since that entire fraction is getting subtracted. For the last fraction, the a is missing the x minus a, so we're going to have the a times the x minus a. Nothing else about this changes. The least common denominator stays, and you need to reduce the numerator. So distribute the x, keep this middle part the same, distribute the a, and you should get x squared plus ax minus x squared minus a squared plus ax minus a squared. Then you want to combine like terms carefully, very, very carefully. Watch your negative signs. You should end up with 2ax terms and then negative 2a squared terms, still over your LCD. And at this point, most of the other problems were finished because you could not factor. This one you can factor. When you look at these two terms, they both share a 2 and they both share an a. Take that out front as your GCF. Again, still over your LCD. And now we have a simplify problem, like we were doing earlier in the unit. The factor x minus a would cancel with the factor x minus a. The only thing you have left then in the numerator is a 2a, and in the denominator an x plus a. At this time, if you want to go back and re-watch any of these examples, I would encourage you to do so.